negative charge is called charge species is called ion. So there are two types of ions, that is cation and anion. The positive charge species, the positive charge particles in a compound is called cation, and the negative charge particle in any compound is called anion. For example, Na positive, H positive, NH4 positive are called cations. So these are the ions known as cations. In anion, Cl negative, OH negative, Br negative contain negative charge on them. That's why these ions are called anions. For example, in a NaCl, that is sodium chloride, you can see in the NaCl, the first species is cation. You can see here the first species is cation, or Cl negative, that is anion. So positive part represent the metallic character of the compound and the negative part represent the non-metallic character of the compound. So now the question arises, what these charges represents. So these charges represent the valency. So the next word we have to learn here, that is valency. So valency is the combining capacity of an atom or group of atoms. What does it mean? Cl negative. It can combine with only one atom. That's why its valency is 1. NH4 positive, that is ammonium ion. So NH4 positive is group of atoms. So its valency is 1. It can combine with only one atom. SO4 2 negative. It contains 2 valency. So that's why it combines with 2 atoms. So the group of atoms having charge are called polyatomic ion. So here it is monoatomic ion, but NH4 positive or SO4 2 negative is polyatomic ion because it contains more than one atom. So that's why it is polyatomic ion. So polyatomic ion is NH4 SO4 2 negative. So the term you have to revise or learn or kept in mind, that is valency, that is combining capacity of atom. So to start with the next topic, that is chemical formulae, you have to open your book on page number 37. Please look at table number 3.6. You can see the different type of ions here with their atomic symbols and valency. You have to firstly learn this table to understand the chemical formulae. I had given you a topic in PDF. Hope you have learned all about the symbols of element as well as their atomic number or their atomic masses. Firstly, you have to learn this table to understand our today's topic, that is chemical formulae. Please learn table 3.6 as soon as possible. To start with the chemical formulae, firstly I had wrote the example of sodium oxide. So sodium oxide, the question is write the chemical formula of sodium oxide. To know the formula of sodium oxide, firstly we know the symbol of these two words. Here sodium, I had wrote the symbol Na. Oxide, the symbol is O. Next we have to write the valency. Valency what? But the atom, the species appear a charge on it. So here sodium has charge +1, that is its valency. Oxide has charge -2, that is its valency. You have to just is aluminium Al. Chloride, that is Cl. The valency of aluminium is +3 and the valency of chloride is -1. You just crisscross and you get Al1Cl3. For a simple whole number, you can write AlCl3. That is the formula of aluminium chloride. So for next is, that is ammonium hydroxide. I will give you the example as possible, and also I had given in PDF the number of different formulas you can try at home. But to try these chemical formulas, you have to learn the table first I had shown on your book on page number 37. So ammonium hydroxide. Ammonium has symbol NH4. You can search this symbol on your table in your book. Ammonium is NH4 and hydroxide is OH. So the valency of ammonium is +1 and hydroxide is -1. Just crisscross, that is this ion get the valency of opposite ion and this ion get the valency of the opposite ion. For this, NH4 whole get the charge 1 and OH whole get the charge 1. For simplicity, we can skip 1. So what we get? We get NH4OH. That is the formula of ammonium hydroxide. So next, you can also write the formula of sodium sulfide. Number 4 is sodium sulfide. Sodium, the symbol of sodium is Na. The symbol of sulfide is S. So symbol of sodium is +1 and sulfide is -2. Just crisscross these two valencies, we get Na2S1. For simplicity, we can write Na2S. That is sodium sulfide. So there are lot of examples you can try it at home. So I have one more for you, that is potassium nitrate. So you can see the next example is potassium nitrate. The symbol of potassium is K and the nitrate is NO3 negative. So potassium valency is +1 and nitrate valency is -1, and the crisscross method we get K1 NO3 1. So for that we get KNO3 is the formula for potassium nitrate. So this is the formula for potassium nitrate. So these are the different chemical formula you can try at home. I will give you the few examples on the PDF. You can also write this one. So we have similarly the chemical formula to opposite. So what is that opposite? If we get this CaCO3, you have to write the name of this chemical formula. So firstly, you just see the symbol of first cation, that is calcium, and that CO3 is carbonate. So what we get? We get calcium carbonate. So you have to keep in mind while writing the chemical formula. Firstly, you have to write the cation, that is metal ion. So cation you have to write first, and the anion you have to write on next. So that is CaCO3, that is calcium carbonate. There is also another example, that is K2SO4. So that is K2SO4. Here you don't need to see any valencies. So here is K2SO4. K is the symbol of potassium and SO4 valency is 2 negative. So the name is potassium sulfate. So what we get? Potassium and vice versa. So here we have firstly known about the different symbols of the metal ions. After that you can be able to write this chemical formula. Firstly learn that chemical symbols at page number 37 from your book. Here is one more thing that is interesting I want to tell you. Here are the different metal ions, that is Fe. Fe is the symbol of iron. So Fe has valency 2 also, or Fe has valency 3 also. Sometimes you can see in your book that the iron has 2 type of valencies. For that Fe has 2 valency or Fe has 3 valency. So in case of valency 2, we wrote the name ferrous for iron. Or for valency 3, we wrote ferric, that is ferrous chloride. In ferrous chloride, the iron has valency 2. In ferric chloride, iron has valency 3. Similarly, we have one more thing, that is copper, that is copper 1 or copper 2. In copper 1, we have valency, it is called cuprous. And in copper 2 it is called cupric. So when we say that is cupric chloride, write the formula for cupric chloride. Here you have to understand the copper has valency 2 and chloride has valency 1. Using Quistron method you get CuCl2. So here I have given the notes of such different types of symbols and their names, which I had not seen in your book. I have given with the PDF. You can write that on your notebook. So here I had completed with the chemical formula. So our next topic is molecular mass and formula unit mass. So what is molecular mass? So as the name indicates, mass, that is molecule contain different types of atoms. So it is the sum total of the masses of different atoms in the molecule. It is called molecular mass. And the formula unit mass is just as it is to the molecular mass, but a different definition. That is, it is the sum total of the masses of the number of atoms in a formula unit or in a formula. So what I told, the sum of the masses of different atoms in a molecule is called molecular masses, and the sum of the number of atoms, sum of the masses of the atoms in a formula unit. So that is molecular mass. In previous PDF, I had given a summary of the different masses of different elements. Here we can use that table. So firstly, in H2O, I have to write the molecular mass of that H2O. What is that definition? Definition is sum of the masses of different atoms. Here we have 3 atoms, 2 atoms of hydrogen and 1 atom of oxygen. What is the atomic mass of hydrogen? That is 1 U. Mass of oxygen is 16. So how we get? That is 2 hydrogen. That is 2 into 1. Because we have 2 hydrogen. 2 into 1 plus we have only 1 oxygen. That is 1 into 16. That is 2 plus 16. That is 18 U. I have told you U is the unit used for the relative atomic masses or relative molecular masses of different species. So the next is HNO3. Atomic mass of H is 1 U, N is 14 U, and O is 16 U. So here how we calculate? We can calculate 1 into 1 plus N is 1 into 14 plus 3 into 16. What is that? 1 is hydrogen is 1, its mass is 1. 1 into 1. Nitrogen is 1, 1 into 14. Oxygen is 3, 3 into 16. So what we get? 1 plus 14 plus 48. That is 63 U. So next, atomic mass of sodium 3 into 16. So 46 plus 12 plus 48. 106. So these are the molecular masses you can calculate by yourself, as I have given you a homework on PDF number 2. You can